Live. Hello, everyone. Thank you so much again for joining me on your weekend and investing more of your precious weekend time with me. I really hope that we can go through a ton of stuff today. But yeah, let's just wait for more people to join onto the live, and yeah, let's have a great time today. I hope everyone's enjoyed their week. Hope it hasn't been too stressful, not too much work. Um, yeah, I've been interacting with a lot of you on the Slack channel that we've set up, and it's really cool. I'm really liking the vibe that we've got on there. Everyone is so awesome and just like really helpful for each other as well. And I'm liking how all the questions are coming in too. So I'm just gonna give it probably another um, maybe a minute or two. All right, Abhishek, hey mate, how's it going? Pranav, thank you. Hello. Yeah, I think this week I actually forgot to send out a reminder email, so I'm hoping that we'll actually get some people on this live. But either way, it doesn't really matter. Really hope that we just have a great time regardless of who's here. Um, yeah, we'll give it probably we'll go up until 2 minutes 30. Sorry for the guys who are already on board. Yeah, so for this week, I actually was just going through, just scrolling on my LinkedIn feed, and I saw some of those really popular articles that happened, I don't know, 2012, 2016, etc. And that got me thinking about trying to provide more insights and more context for everyone. So hopefully today we'll try and cover a lot of that stuff. So we're almost, yeah, we'll just give it a few more seconds and then we'll get started. Yeah, I only finished preparing all my material around, I don't know, 15 minutes ago, so I'm kind of like in a bit of a rush right now. So I just need to try and calm down, and then we'll try and ease into this session. Okay. Yeah, let's get started. So hello, everyone. Thank you so much for joining me on a Sunday, 21st of June, for the fourth episode of Data with Danny, live personalized mentorship for aspiring data scientists. Thank you so much for joining me, and I hope that I can share more insights and thoughts to help you guys on your data journey today. So I'm going to go to my iPad. Most of today will be spent on the iPad as well, but we'll definitely do a lot of Q&A. All right. So for today, what I wanted to cover was the origin of data science, and in relation to some of the really popular articles that we've seen in the Harvard Business Review, as well as the Economist and Forbes. And I wanted to talk around what is data science, how did it emerge, what is modern data science, how has it changed over time. So this is that second component that we'll hopefully go through. And also just my take on what is data science now, how has it changed, and what might it look like in the future. And the most important takeaway is I want you guys to think about, why is this so important to know in terms of the history of data science, the origin of data science, how it all came about, and also how am I going to use it to try and help me with my career. I think, in a nutshell, the thing that I wanted you guys to think about was, using all of this knowledge, how do you build a really strong vision? How do you guys try and use all of this knowledge to try and picture where you want to be in your career, not just in terms of getting that entry role, but a few years down the line? What areas do you want to work in? What problems do you see yourself solving? What sort of technology do you want to use? Hopefully some of these stories from the original, let's call them godfathers of data science, maybe it will inspire you and give you a clearer picture of where you want to go in your future. So I really hope that we can cover that off today. And after these three, what we're going to do is probably a ton of Q&A. I'm not sure how long all of this stuff will take, but yeah, definitely we're going to do lots and lots of Q&A. So hope you guys are ready. Okay, so you must have heard this before, but the main quote was data scientist, sexiest job of the 21st century. And this is coming from a 2012 Harvard Business Review article that was written by Mr. Thomas Davenport and DJ Patil, or Patil. I don't know how to pronounce his name properly. But these guys were kind of on the forefront of data science for a few years before they actually published this in 2012. And what I what how they actually start the article, they actually go through a famous story about Jonathan Goldblum, who I think was DJ Patil's boss when he started working at LinkedIn. So I'll take you through the story, and hopefully it will give you a bit more insight around what the original data scientists were like. So in 2006 June, LinkedIn hires Jonathan Goldblum, who is from Stanford with a physics PhD. They had a business problem. So on LinkedIn, they had 8 million active users. So I don't know how many LinkedIn users there are now, but there's probably a ton more. But their main problem was that it was lacking that social experience that people wanted from a social network. On the article, they actually talk about how people would sign up, and then it's sort of like you go into a conference, a business conference, where you know absolutely no one. None of your friends are there. There might be different people from various industries, but you don't know how they're related. There was just nothing. You just kind of you go to that conference and you just stand in the corner, and then sooner or later you're like, oh, this is a little bit awkward, a little bit boring. I'm gonna go home. So that was what the experience was like around 2006 June or so, according to this article. So what happened was they brought in Jonathan Goldblum with his very strong physics background, and he came in and they told him, try and solve this problem, try and figure out what's going on and see if we can improve the experience. So what he did was he started analyzing some of the data that they had from their profiles. So you know all the things that we fill out in the About Me, some of the previous history, the companies that we've worked with, the different experiences that we have, all of those skills and all those different things. They were using that sort of data to analyze. In this case, for Mr. Goldblum's case, it was for the linkages. So they wanted to try and figure out how do we try and link different customers together to try and make it a more social experience. So what happened was when Mr. Goldblum was thinking through the problems, he kind of realized that this linkage activity was very similar to how they can kind of do graphs and linkages within the physics world. So there was a bit of overlap between what they did in research and in academia, and then they tried to apply some of these novel ideas to their exact business problem. And this was trying to make it a more social experience. So what they did was they used that data and they ran some analysis on historic data to prove that they could predict the user's network behavior. So in this case, it was more around can they predict using historic data which other people certain users will network with in the future. And after doing this analysis and proving their point with the proof of concept, apparently the story goes that Reid Hoffman, the then CEO of LinkedIn, actually allowed Mr. Goldblum to go and run some live tests on the customer website. So let's say this is like your LinkedIn feed, and then you get like all these feed buttons and whatever. Maybe they had something on the side where it was people you may know. So this was the original of what the LinkedIn, that product was, that algorithm that was recommending people that you might know. So what they did was they actually ran little mini tests to prove that concept and the experiment was working. And then actually what happened was that led to really, really great uplift, and the click rates went through the roof. And that eventually led to a lot of growth in LinkedIn. And then over time, they made this into a full-blown thing. They released the feature as part of their app and their mobile experience and their online, and it just really took off. So this is the introduction story of this Harvard Business Review article in terms of introducing what a data scientist does, or what was a typical project. I'm not sure if this is really typical, but it's one of the ideas. So following on from this, if we take this as the example, we can kind of break down what data scientists kind of did in 2007 through to around 2012 when this actual article was published. So to break it down, I've kind of simplified it into 6 basic steps. But the first one was, usually people thought of them as really great problem solvers. And because in this time, most of the problems were done in a tech space. So your Facebook, Google, Amazon, LinkedIn, all of those guys were the major movers. And I think the term data scientist actually originated from DJ Patel and another guy, I think it's Jeff, I forgot his last name, from Facebook, where they were the head of data analytics or data products, and actually came up with the term as well. So I'm going to go through later why the term scientist kind of stuck as well. But to start off, most of these data scientists in this time period were very good problem solvers. They could think very innovatively, and they could try and apply non-traditional techniques to try and solve problems, especially with the data. And that takes me on to point 2, where they had the ability to handle messy, unstructured data. So you have to remember, before this 2007 and 2012, there was definitely still data that was being used in a lot of companies. This was traditionally, let's think, big SQL databases, things with rows and columns, lots of tables, etc. So this is not to say, oh, I didn't realize I was writing behind my face. This isn't to say that data scientists were, they kind of, data was always being used before this time, but the modern term of data scientist kind of didn't show up until around 2007, according to this article anyway. But one of the key things was the ability to handle messy, unstructured data. So think of the LinkedIn profile. What sort of data would that look like? Chances are it probably wasn't in a row and column structure. It must have been something like some nested dictionary or something, JSON structure, something which was more complex and required a lot more effort to try and clean up to make it usable with other tooling. So let's say, after they were doing the unstructured data, the next step was to, okay, so Mr. Data Scientist or Mr. or Mrs. Data Scientist, you've now created a cleaner data set from this really messy data. What are you going to do with it? So then they would analyze the data. And the main point here is that most of these data scientists in the past, they were creating hypotheses, like hunches or provable and testable hypotheses and ideas that they could actually use the data to figure out whether they were onto something. This requires definitely a lot of stats, some experimentation thinking, but a lot of it had to, I think this is part of the reason why the scientist term kind of stuck, because scientists are really good with the statistics and really good with designing and running experiments. So after they tested these hypotheses with the historic data and proved that they had something that was going on, these guys would then run live customer experiments. So in the previous slide, we were talking about how Reid Hoffman let Mr. Goldblum run some more tests in terms of running live customer ads on the LinkedIn pages, the most popular pages, and then they were tracking all the click-through rates and trying to figure out whether that was a successful experiment. So after you run these live experiments, so clearly the data scientist would have to work with some of the engineering teams and different things to actually get it into the system. After all of those results come back, they have to go back in and analyze the data. So I probably should add this step here. So for sure, the data that comes back would not be very clean as well. So they'd have to have some processing to actually clean it up. And then maybe after that, let's say all the data looks good, they summarize their results and everything looks perfect. They then have to communicate what happened and the results and the impact that it will make to the business back to the CEO and all the different parties and the business managers. So that's here in step 5, which is really important as well. That's why we focus a lot on communication, data visualization, trying to convince the stakeholders that your idea is a great idea requires really good interpersonal skills. And let's say the business really likes it, then the last step would be, how do you launch that as a data product, which I'm going to cover later in this session as well. But how do we actually continue getting a lot of value from this first proof of concept and really launch it into these massive data products that we're very familiar with now? So in a nutshell, we covered this a little bit last week, where in this red box, here, where in this article, they think of a data scientist as a combination of data hacker, analyst, communicator, and trusted advisor. So it's very similar to what we had in terms of the Venn diagram and the ABCs of data science that we covered last week. But you can see how this is what we typically call, these days, we call it maybe FAANG data science. So this is, I think FAANG would be Facebook, Apple, Amazon, Netflix, and Google. But kind of like the forerunners of the tech space. And this is what they used to do in the data science world. So they would be really good problem solvers, create some hypotheses, run some experiments, communicate the results, and then eventually launch it out as a full-blown product. Okay, so this is what data science was like in the early days when they first started. So you can see that there's a ton of stuff here, and the skill set is very varied. There's a lot of different abilities and different hats that you have to wear along the different process. I think that's why in the past, data scientists were kind of always seen as the unicorn, the business changer, the guy, the people who can enable really large step changes from what's happening now to a new growth state. So now we're going to say, why did the term data scientist stick? In this article from the HBR, one of the main points that they highlighted was an intense curiosity. So think of the best scientist would be very, very curious. Think of Einstein or anyone else, anyone that you can name. One of the things that they would do, amongst many others, would be trying to find out why, asking those questions. So there might be a problem. The next step would be asking and collating all those different questions to ask the people who know, or the data, to try and figure out what some hypotheses are. So I think there's a really famous quote by Einstein where he says, like, if you give me 1 hour to solve a problem, I'd try and come up with lots of questions for you in the first 50 minutes or something like that. So I think the intense curiosity is very, very valuable. And this is why I think people, in terms of those tech companies early on, when data science was just coming on, they really thought that the scientists who they hired out of PhD programs came in and they naturally had this intense curiosity because they were trained to have it through their entire scientific thinking. So I think this is part of why it actually stuck, because originally a lot of the forerunner data scientists were coming out of those PhD programs, master's programs, and they were researchers essentially. And the main thing here is also to think of the hypotheses. So it's very good to ask lots of questions about the data, about the business. But in the end, these guys, when they think of science, we instantly think of hypotheses, proving whether something is right or wrong, or whether you can do a prediction or not, whether it's going to actually make a difference. These things must be testable, because you can come up with a ton of different hypotheses which aren't testable, and that's not really useful. But yeah, I think the science and the hypotheses and the scientific thinking is super, super important, and maybe that's why the term really stuck. So that's number one. Number two, from the article, what they said was they didn't want to use the traditional terms of data analyst, because they back in the day, I think in the 1990s, a lot of those PhDs and math majors and all those guys with really good mathematical and computational background, they all went into Wall Street as quants, so these quantitative analysts, where they would use their skills to look at all those structured time series data from the financial markets and make a prediction for what to trade, what to buy and sell. And they also wanted to depart from the traditional data managers. So think of your DBAs, some of the guys who are working in the background to manage all the data in the traditional row, column, table, database type data sets. So they wanted to specifically depart from that one because they dealt a lot with the unstructured data. So think of the images, the text that was coming out. Google did a whole thing where they just scraped the entire web and pulled out all of those texts from each website, and then they did some algorithms with that. So it's a different type of data structure, and that kind of leads on to the part three, where there's structured versus unstructured data. So I think of point two as more, they wanted to break away from the existing, and point three is more around the reasons why in terms of the structured versus the unstructured data. The size and the speed of the data is also very different. So they kind of wanted these new data guys or data scientists to come up with novel solutions and really be pioneers in this space where no one's really done anything before. And then eventually, a lot of these scientists, if you think of scientists over time, a lot of them were crazy inventors. Think of lots and lots of different inventors were actually scientists. So in the end, I think a lot of these data scientists also created those data products that we were talking about. And that really led to an explosion in growth in a lot of these tech companies. So you can imagine Google was very successful because of their PageRank algorithm. LinkedIn really grew a lot because of this people that you may know data product. But I think these are some of the reasons why the term data scientist stuck, because the scientist component really leads to this hypotheses. They wanted to break away from the original existing thing. They had different types of data in terms of size, speed, the velocity of the data that was coming through, the types of data, the images and the text versus the rows and columns. And they also wanted people who could actually deal with all this ambiguity and kind of be pioneers. And then also they wanted this creator type. So they wanted to build things from it, inventors. Okay. So you might be asking yourself, what are data products? I know when I first started and when I first read this article, when it came out in 2012, 2013, I don't think I actually read it until 2015 or something. So I was a bit late to the game. But yeah, when I read it, I had no idea what a data product was. I think I was very maybe naive at the time and just thought all the data was in SQL and everything. But here are a few examples of what data products were back in those days. So you can think of, I talked about the Google PageRank, the LinkedIn people you may know, the Facebook newsfeed. I don't know whether that actually was being a data product back in the time, but it's a bit more relatable. So it recommends you which feed items that you might click on, you might share or comment on, those sorts of things. The Netflix recommender engine was very, very popular back in the day as well. They actually ran a really large competition for data scientists and machine learning people to try and predict and beat some benchmark in pretty much the original form of Kaggle. And that was really, really popular. But you can, in Netflix, you can, when you're scrolling through and watching different movies, based off your past viewing behavior, the engine will recommend you what you might look at next. And also the famous Amazon product recommender, where you get recommended products based off your shopping behavior and kind of your similarity to other customers as well. one of the main things is these all have certain things which are very common. And I kind of gave it this little acronym just so you can try and remember it a bit easier. It will be GV dabs, like when you're dabbing. I thought it was just an easy way to remember it. But the G would stand for growth. All of these are massive growth enablers. There's also a ton of value in all of these different products. So you can imagine just how much like monetary value each of these algorithms and the products actually made in terms of the business that they were running with it. So growth and value, they're all digital. They use algorithms at their core to try and predict certain customer behavior or trying to understand some of the data coming from pages, like in Google. They all use big data. I'm pretty sure no one will repute that. These are all large data sets, and they all need some sort of integration with certain systems. So the algorithms, they might work really well by themselves, but if they don't actually fit into the overall system in the major product that they're actually using, then you're not going to get any value from it. But these are all the things that are kind of that are common between these data products. Okay, so I have a question here. I think, oh, yep, Pranav mentioned that Microsoft should be there also. Yeah, I really think so, but I think the term the FAANG is just the common one. I think these days they add on a ton of other companies as well, like OpenAI, Tesla. Yeah, like you can imagine there's tons of them. And Microsoft should be there, but for some reason, no one really put it there. So I'm not too sure. I have a question here around data products. Are they the same as events? It really depends on who you're asking. In my experience, I've actually built a data product, which is kind of all the different customer events that are coming through for in a retail space or in a banking space. So you can imagine all the different transactions that customers did, the things that they viewed on the different web pages. In my mind, when I think of the data products, there might be two different classes. So there's one which is, let's go machine learning data products. So they're all algorithm based. That's like these guys. And maybe the other section or the other branch of it would be just more like traditional data assets. So you can think of, like, for example, my customer event store. I would call that a data asset because I didn't really have to apply any machine learning, but I did have to do a lot of data manipulation, SQL work, trying to understand what all the different joins were. I tend to bundle them more along the traditional data asset side, whilst these data products are kind of coming from data science products. Maybe that might be a better term for it, maybe. Oh, this is a great question as well. So, yeah, in the popular media, they also were saying how the Netflix prize, the people who won it, and they built a really complex algorithm. The algorithm was never actually used in production because it was so complex. So I think that's another really key point in terms of when you try and build some machine learning solutions or build up some of the algorithms that you want to use. There has to be a balance between how complex it is and how easy it is to deploy into the existing systems or to integrate it. So sometimes if the cost that it takes to actually run the algorithm is really high, there's little to zero chance that it'll actually be used in the final product, the data product. But that's why we see a lot of data products are actually run by relatively simple algorithms. So I wouldn't be surprised if back in the day, this LinkedIn people you may know, like maybe it was just using logistic regression. Who knows? Like maybe they were just really simple algorithms that was underlying it. Or they had different data structures like graphs or different things that they could use, which are relatively simple to build in production systems. And then you can have a lot of value out of it. Okay. Um, yeah, this is a great question as well. Do they have multiple machine learning algorithms for a single data product? I'm almost 100% sure that they will have multiple algorithms. It might be so for the page rank. I'm not too sure. I'd have to do a bit more research, but I think the overarching concept of the page rank algorithm might be a little bit different in terms of the different types of algorithms that were being used. In the LinkedIn people you may know, they might be using a few classes of algorithms. So they might be using that logistic regression. Maybe they use some graph models as well. But I'm almost certain that they would have multiple instances of them that were trying to predict different things. So usually, when we think of the machine learning in production, you would have maybe a few different algorithms and they would be predicting different things. But then there might be another layer that kind of uses all of these insights and serves them within the whole system, and that whole serving with the integration with all the different models determines the entire data product. So I hope that gives you a bit more idea of the space that the data products is in. Okay. I'll answer this one as well. So I think for cybersecurity, I don't have much experience in it, but I'm sure that there are tons of data products in there as well, like fraud prediction or maybe false clicking, or the thing that Google has where you have to actually click on the tiles that has the fire hydrant in it or the bus. I'm sure that those can also be classed as products, but I'm not sure if there's actual machine learning used in there or whether it's just a simple if else. If the person doesn't click on these things, then it's clearly not a person or something like that. So I'm not 100% sure, but there's definitely a lot of applications in cybersecurity as well. Okay, so I hope that covers the data products. And I think when we think of the origins of data science, a lot of the data science came from these products. So a lot of the people who are working in the data science teams would be specifically focused on doing their algorithms and their work to promote these products and to try and grow out what the networks were within these areas. So that's a key point to know. All right. So I'm just past 9:30, going good for time. Now, in this same article from the Harvard Business Review, they also had a few key, maybe not predictions is not the right word, I might go insights. So what they thought of in 2012 when they published it was the first point that I took out of it anyway was that the people with skills that are required in this space of data science is more important, or I think they said is at least as important as the tech. So go is that's why I did the inequality sign here. So they were very bullish on the people need to learn the skills to be able to interact with data and solve these problems. The tech is just the enabler that lets these people do it. So I think when they talk about the skills, it's yes, you have to be able to code, but you should be able to apply any sort of thinking and tools to actually solve the problem. And these are the main skills that people were talking about. And what happened, I think, in 2012, there might have been one or two university courses that were doing data science, but now, yeah, there's tons of them now. So yeah, they're pretty spot on with their prediction of more uni courses. Another takeaway from the article was for data science, people with a strong background in data and computing are more likely to get into the field. I think this is definitely spot on. I'll give them a green tick for this one. I think over time, what we're seeing now is that the people who understand the data, there's actually not many people who are really good at understanding data. I think this is where you hear a lot of the headlines where it's saying, oh, I forgot the number, but there's 20 million jobs or something in data that will be created by 2020. Maybe I'm just making that up, but there was a lot of different headlines that said that there was a ton of jobs, which like there's a lot of under supply of talent in this area. And yeah, I think right now the area is within the data. We need more people who understand the data really well. And over time, what we're going to see is a lot of the computing. I think back in 2012, 2007 to 2012, there was less people with the intersection of these two skills in terms of data and computing. So I think now in 2020, I wonder if this has changed much in terms of do we need more people to understand the data and try and figure out what the actual problems are, or do we need more people who are really good with the computing? I still need to think through that a lot more because I'm not quite sure what we're missing at the moment. So I'll have to think a bit more before I share more of my thoughts. Okay, another insight that they have from this HBR article was traditional analyst skill sets won't cut it. This one is disputable, definitely. But I think at the time when they wrote this article, it was about that type of data scientist who was the pioneer, who could deal with all this unstructured data and kind of wrangle it and clean it and get it all into one place, and then do their analytics and stats and build the models and all of that stuff. So I think they're quite valid in terms of the traditional analyst skill set doesn't necessarily have those components in there. These days it might change. I think what we're seeing is more and more jobs are requiring analysts to actually have some exposure to at least the hypothesis testing and the different analytical skill sets, and maybe a little bit of machine learning as well. So maybe this will change over time. So in one of the predictions, or one of the insights, was one of the hiring managers was saying how they would not necessarily hire people based on analytical talent alone. So let's say you came out of a master's in statistics or mathematics or something, and you have really good analytical skills. I think the guy was saying how he would prefer someone who could actually build a working prototype of something in whatever language over the person who just had the good theory background. That was quite interesting for me. I think definitely the ability to develop a prototype means that it demonstrates that you're very pragmatic. You have good end-to-end knowledge of what's going on. You're definitely a great programmer if you can do that as well. But I think over time, these will kind of merge. So it's sort of like the ability to develop a prototype will be the way to demonstrate your analytical talent as well. I'm definitely seeing that now where everyone's trying to do end-to-end projects where they're demonstrating, oh, here's the unclean data. I do all these steps to clean it up. I build my model. Then I demonstrate what sort of use cases that we can use the model for and how we can run experiments with them. So this is definitely changing over time. Here they also said on-the-job training is critical. Yep, 100%. I don't think anyone can disagree with that. For me personally, I learned so much more when I was actually working in a data science team than what I was learning by myself. Luckily, I didn't pick up too many bad habits, / I didn't actually have to learn, or I learned quite a lot by myself, but I learned way more, and I kind of just absorbed from my mentors much more than what I learned myself. So that's another reason why mentorship is, I think it's really, really important. In this article, they also talked about ethics, standards, and regulation as kind of the things that will be challenges for machine learning data science in the future. We definitely see that as the case with the current environment, especially. We'll talk more about that later, but in terms of the ethics side of using data to predict people's behavior, of course, there's some ethics in there as well. The standards is what happens when someone breaks the ethics code. How do you reprimand them? What happens to them? Can they just leave their current job and go to another job and kind of sweep it all under the table? I think, yeah, that's another tricky area. Probably I'm not very qualified to talk about it, but it's more just an interesting thing to think about, I think. And the regulation is more around privacy of customer data, for example, is a very key regulatory point at this current moment. And the last point from this article was there's bound to be heavy expansion into traditional industries, as well as new industries will be created as well. And I think this is really important because it means that you have to broaden your current view of where data science is being used now, and you can try and think of new areas or new problems that haven't been solved, and you can kind of take that on as a goal for what you want to work on, and that will make it easier to kind of work from wherever you are now to kind of bridge the gap between where you are now and where you need to go. Okay. So I think this is it from the HBR article. The data scientist is the sexiest job of the 21st century. What I'm going to cover now is let's fast forward through a few more other articles. I'm not going to go in as much depth as that original HBR article, but I'm just going to share some of the sound bites that were taken out from key articles that were coming out from 2017 through to 2020. The first one is from The Economist, where they declared that data is the new oil, where they kind of put out a lot of metaphors and analogies to how the data is kind of like the raw resources and all of the different steps that you need to refine the data in the foundry. You need to separate all the different elements and all that different sort of thing before you can actually get value out of the data. The Economist kind of tried to cover that in 2017. What they focused on in that article actually was they focused more on the negatives, so the downsides of the data is the new oil. It was more of like a negative focus in terms of what could go wrong, and they talked about anti-competition, privacy regulation, and the ethics that we were just talking about previously. I think at the time, Facebook acquired WhatsApp or something for a $22 billion US. And I think they used that as a key example for anti-competition. The way they tried to frame it was Facebook bought WhatsApp because they were a competitor, and they kind of bought them out really early with a really large price so that they can maintain their monopoly in the digital landscape. I thought that was pretty interesting. So The Economist also released another one where they talked about data is giving rise to a new economy. So when they talked about the new economy, they were talking about definitely creation of jobs, which is positive for all of us. There's also, they really talked about how data is going to be used in this brave new world. And also it's the importance of having fresh data. I'm going to write that down. I think that's quite important. So I think originally what people thought was data is not the thing that's going to change the world. It's algorithms. Algorithms will change the world. The data is just an input for the algorithm. What we're seeing now is more that the algorithms are great by themselves, but if you don't keep feeding it fresh data that's relevant and timely, then it might just be wrong, and you'll never know that it's wrong because you always thought that your original algorithm was the best. So fresh data is very, very important. And I think this article also talked about different things such as data as a service and data platforms as a service, where they're trying to think of them as kind of the middlemen between the data generators, which are myself, yourself, all the different sensors that could come around from different products that we're using. I think Tesla, each self-driving car generates 100 gigabytes of data per minute or something crazy. A lot of the new innovations and economies will be around how will you store that data, how will you use that data, how do you actually clean it so people can use that data, all these sorts of questions around the usage and the distillation and how you actually get the value out of what's being captured was raised in that article. I thought that was really interesting as well. what does it mean for us as practitioners and data scientists? I think having really good understanding of the context of where your data comes from, who is going to use it, as well as all the different transformation steps that are required, gives you a good, larger context of the whole problem. And I think it can only help in terms of trying to figure out new solutions to problems that you might have when you're working on a business problem, for example. Okay, so Economist was talking about all of this stuff. Data is the new oil. There was lots more focus on the data starting around 2017. So there was a departure from kind of like the experimentation and the data products, and it moved more towards around like, oh, we need to really make sure that the data is correct. Otherwise, all the stuff that we're doing is, there's a term or there's a saying that we usually use where it's garbage in, garbage out. So it was more focused around that sort of stuff. So in 2018, there were a few Forbes articles where they tried to say, oh, data is not the new oil. And the tagline was that it's actually better than oil. I think the main analogy was that oil is a non-renewable resource. So once you take it out of the ground, it's kind of gone forever. Whilst data, we will be generating data for probably the rest, like for a really, really long time, for the foreseeable future, and there'll only be more and more of it. I thought that was a really important point. That kind of leads me to think about, for us, in terms of what does it mean for practitioners. It will be, okay, chances are big data will be the normal data. Big data will be the new norm. There'll be tons of different data sources. So what we can imagine now in terms of sensors and transactional data and the image data that's coming out from your newsfeed and everything like that, those are the things that we can imagine currently. But in the future, what new data sources are we going to have? That will be a really interesting point as well. And it's a good thing to try and keep in mind. And one of the most recent articles that I read that was really thought-provoking was another HBR article. This time it was released just this month, actually, and it was called "The Dumb Reason Your AI Project Will Fail." And in a nutshell, the dumb reason is that nothing is integrated properly. So this talks about the knowledge that you need to actually build these AI data products and actually get them into a position where you can actually generate value out of it. So I think these AI projects, what they're talking about here, they are analogous to those data products that the original data scientists were working on. I think there's a bit more maturity around the platforms that these data products now live in and get served on. So you can think of, for sure, there'll be some cloud computing, all the different data pipelines that get used to actually make sure the data goes from somewhere to where it needs to be. And for sure, there'll be algorithms and machine learning as well. So the challenges will be, how do you manage all of those things to actually build out the product so it can give you value for your project? But yeah, these are sort of like the transition from the original data scientists from 2007 through to 2012 through to now the issues are more around the algorithms are cool, but what about the data? What about the integration? How do we manage all of these things so we actually get ongoing value? And I think a lot of this, the dumb reason why your AI project will fail, maybe one of the core reasons is that not all companies are like Google, Amazon, Facebook, where their systems are very mature, where they have really good production systems, where data scientists can just kind of clunk in their part into the wider ecosystem and it will just work. So what we're seeing now is kind of like a new wave of machine learning and algorithms, not so much in the techniques, but more that new companies are starting to use a lot more of the machine learning within their processes. So it's sort of like people are catching up to where the Facebook and Googles and Amazons were roughly 10 years ago or so. Yep. Yep. That's exactly where I think these AI projects are. Maybe yeah, they're more on a smaller scale, so they won't be such large social network type data products. But definitely, yeah, smaller companies will be trying to build data products slash AI projects, and they really need to get them into production systems to get ongoing value out of them. Okay, cool. So now let's talk about what data science is in 2020 in terms of here I've actually put down I know I've just got 5 different examples here, but I'm sure there are plenty more. I think these are kind of like the main personas that kind of jumped to my mind when I was creating these slides. So I'll just quickly go through them, but you essentially have the first one, we're going to call it the sexy FAANG data science, where they kind of get to use all those new tools. So the big data, the cloud computing, they work on those data products that we were talking about. They have to do great data visualizations to convince the business that whatever their experiments were actually very successful, and also the value that their new data products will bring to the business. And there's also a large focus on experimentation platforms and frameworks. Um, so that's the sexy FAANG data science, where I think when people think of going into data science, that's what they're seeing, in addition to this machine learning research down the bottom as well, which I'm going to cover later. But yeah, I think the FAANG data science is definitely one of the archetypes in 2020. It's still a thing. Um, the second type of data scientist, I think I've put here advanced data analysts. But what I wanted to stress here is imagine like the really great analyst who's looking for that $1 billion insight. And you need a really great skill and in-depth analytical ability to think through not only how to do it with the data, but also whether your solution is correct for the business. So I think of this advanced data analyst, almost like a principal data analyst type person. Sometimes they might be called a data scientist as well. Um, the third one, I've put data visualization experts. These ones I think of more like interactive data visualization. So you might have heard of rshiny, D3JS, but these guys are almost data scientists slash data visualization engineers, where they work in more software heavy areas to actually build really awesome data visuals and things that would go onto a website, for example, where you kind of click through the different things and they tell you a really nice story. But they're mainly focused on a lot of new cutting edge ways to visualize and represent data. Okay. The fourth type is the very common one. So it's the applied machine learning type data scientist. So I think this is where a lot of my experience has been, where we use a lot of the data science and the algorithms to try and solve the business problem. Maybe we don't get as far as this FAANG data science, where we actually go and deploy a data product. Maybe we don't actually build any experimentation frameworks, but we kind of have to, we run a lot of prototypes and proof of concepts. And if they work, we'll try and deploy them into production systems. So this one is, I think the majority of data science roles is coming in through here at the moment. And the last one is the machine learning researcher. So I think of these guys as like your Google Brain, for example, where they're really on the cutting edge of machine learning research. And for these guys, what I actually think these guys mostly, they have a PhD. They have a really strong research background. You might think of like OpenAI might be another example, where they're doing a ton of machine learning AI research. I think that's another section where people really focus on when they think of, oh, what I want to be a data scientist. I want to do that. And that's more on the more difficult end, where you need really specialized research knowledge to actually break through into that area. On the right here, I kind of talked about what are some of the industries that are using data science now. And yeah, just looking through all of them, there's a ton of different industries, like probably every single one that you can think of. They could be using data science if they're not already using it. Here I've just got digital, retail, supply chain, heavy industrial, energy and resources, education, health, medical research, finance. Like, yeah, there's tons of them, and this list could go on and on. Why knowing some of this is really useful is you can kind of, like I was talking right at the beginning, knowing this information, you can kind of picture out where you want to move your career towards. And I've always thought when you have a really good and tangible goal that you want to work towards, it makes it much easier to kind of break all those steps down into bite-sized chunks that you can actually tackle and make it manageable and achievable. And you can kind of do that across like over a shorter period of time and actually still get to your goal relatively quickly because you're moving through with so much energy and momentum. Um, but yeah, this is all I've got for this live in terms of the prepared material. I hope you guys enjoyed me talking about the HBR and the origins of data science and why I think it's important to kind of know where this sexy data science role originated from. And yeah, I hope you guys had a great time. I'm going to go to Q&A right now. So yeah, the rest of this session will just be a ton of Q&A. So please hit me up with anything in your comments and I'll try and respond to everything right now. Okay, first on. Imam, thank you for your question. So, is there a hype around deep learning algorithms? Do people use them in industry, or are they still in research domain? So, I read quite a few different articles whilst I was researching for this session in terms of the importance of deep learning and all those different things. The main takeaway that I got from a lot of the articles was that there's definitely deep learning is being used in different industries, and depending on the maturity of the systems and the data platforms that are being used for different industries, there may or may not be deep learning being used in production. So, for example, all the self-driving cars, etc., there's deep learning there. In Google and a lot of the tech firms, there's definitely deep learning in there in production also. I know in Australia we don't have so many deep learning use cases, so a lot of the traditional machine learning algorithms are still being employed in banking, retail, insurers, and all those different things. I think the only place in Australia, at least, where deep learning is used extensively is there are industries which deal with imagery. So, say, imagine satellite imagery. Maybe there's some stuff where they're trying to extract information out of text, where a lot of the deep learning is very powerful and much more powerful than traditional algorithms. So, some of the niche companies which live in those areas definitely will have more of a deep learning focus. But the mainstay for a lot of the current applied machine learning is still within traditional algorithms, and it's more a problem of trying to identify the problem that you're trying to solve for with the machine learning. So there's still a lot of business interaction to try and identify exactly the problem, set up the prediction, figure out what metrics you want to use, and all of those things are, I think, in my mind, more important than learning very in depth about the deep learning in terms of, oh, do you need to know all the nuts and bolts of what's going on underneath? Do I need to be able to build really complex architectures and explain why a certain architecture should be used over another one? I think it's really interesting. Like I really enjoy reading about that stuff, but I haven't had too much of a chance to actually apply a lot of that learning to what I actually do at work. So I think it really depends. Like I think if you're really passionate about it, and you definitely want to work in that area, then knowing that really deep level of knowledge is awesome. And I think that will really help you if you wanted to move into areas where deep learning is being used extensively. But I think they are more of that sexy FAANG area where they're using a lot of the more complex tools and models in there. So obviously the competition will be much higher. But I think deep learning is really cool. I know a lot of my memes are kind of playing with the idea of deep learning being not so important, but yeah, I think it's definitely a really good tool set to have, a tool to have within your tool set, definitely. Okay, I'll go with Ayush. Okay, as data science is a highly maybe technical field, I'm not sure. How do you think it will? Oh, maybe it's a highly evolving field. How do you think it will evolve in the future from 2020 to today? Okay, I think. So these are just my predictions and my own thoughts and feelings. I think that a lot of the data manipulation and the cleaning and all of that sort of stuff will get standardized over time. You'll see a lot of the traditional steps where we prepare all the data to feed into the machine learning algorithms. A lot of that will get automated. There's companies like Data Robot who is already fully automating a lot of that as long as you give them all of your raw data and they kind of massage it with their proprietary tools. I think, yeah, a lot of that. It's people always talk about it to say like, oh, 80% of the data scientists' valuable time is being used to clean data. So if we can reduce the amount of time that they clean the data, we should be able to get 80% more value out of them. I'm not too sure about that, but there's yeah, definitely there'll be innovations in the the automation of different tedious tasks that data scientists work on, and things that will make automated machine learning much more efficient over time. But I think there'll always be a place for people who can answer questions and do problem solving. A lot of the time, you might know all the different algorithms, but if you don't know really well what the problem is that you're solving, your knowledge doesn't mean too much in the end. So I would say the technology will keep moving. There'll be more and more automation. Try and identify the areas where it's less likely to be automated away. And a lot of that is the thinking component, the scientific thinking and the problem solving. That stuff I don't think will go away unless we build like some general AI or Mr. Elon builds something amazing that replaces all of us. Okay. Um, I'm out of water. Okay. Let's go with this one. How important are general software development skills and mastery over general coding and algorithms for data science roles? Okay. I had a really interesting picture about this from my last live. Let me see if I can bring that up quickly on my iPad. But I would say software development skills are really important, especially not just for now, but definitely in the future as well. So what we're going to see is a lot of the data science, the stuff that can be automated will get automated, and the things which are difficult will be increasingly difficult to program as well. So having good software development skills will help you to actually bridge that gap and to actually solve the problems in the new and innovative ways which you wouldn't be able to do without the software engineering skills. Let me just have a water. Okay, so here's the picture that I was talking about earlier. So here, I kind of have the skills on the x-axis, so software, business, maths, and stats, and it's high, medium, low on the y-axis. So if we look at the data science one, so here on this side, data scientists, I think it's pink. I've put that they require medium level of software engineering skills. Um, Over time, what I reckon will happen is that as the specializations across the different areas of the whole data science, machine learning, engineering, and different things kind of become more and more apparent, what we'll be seeing is maybe the data scientists over time. One of the predictions from the HBR article was that maybe their software skills will go down. There'll be less of a demand on really good software skills. Personally, I'm not too sure about that because I think for let's say you are a data scientist now and your software skills are okay, like not too bad. Um, it doesn't make sense to try and forget all those software skills and just kind of rely on your analytical skills to actually get you closer to solving whatever problems. I think coding will always be a mainstay for any data role, data analysts, data scientists, engineers, anything. And there's definitely incentive to continue improving. I think your question was asking around do we need to get to mastery level? So like we're talking about like ace programmer level. I think we probably don't need to. Probably the most feasible will be to try and work really closely with any engineers that within the area that you work with, because there's general programming as well as very specific machine learning and data engineering programming skills that we should be picking up as data scientists. So I think, yeah, networking with the people in those roles to try and learn what the gaps are and then try and learn from them exactly how to do things their way is very, very valuable. Okay. Um, let's see. Yep, Kriti. Yeah, I think I just answered that one as well. So, do data scientist job profiles require a lot of coding? Um, I think they usually what we see is for companies where they are less mature in terms of the data science, they there's one of two things that happens. There's either one, they expect the data scientist to be the Google, Facebook data scientist, where they literally do everything and they can code everything as well, or they don't know what they're looking for and they kind of just want someone to look at their Excel spreadsheets or their data and tell them what to do. So if it's the latter type, I'm not quite sure if that, like a lot of people will say, oh, that is still a data scientist because you're trying to help businesses get value out of their data. But in the stricter definition of what a data scientist is in terms of the skill sets that are currently used to define what data science is currently, I'm not quite sure if that will stack up. So I think coding will always be there. Whether it's a lot or a little, I think it depends more on your seniority. So if you come in as a junior level data scientist, there are two different paths as well. You either come in as a non-technical type and you stick with doing a lot more of the analysis, or you come in as a very technical type where you come from a software engineering background. So they usually have two very separate career paths, but the analyst type will still do a lot of coding. And the software engineering type will do a lot more coding than the analyst type. So yeah, coding will always be there. And it's very important to continue upskilling and improving your skills in that area. Okay. Really liking the questions here, actually. Don't know which one to choose. Okay, when handling data, which should come first, data cleaning or exploration? I would it's a really good question, actually. So I would say if the data is so messy that you can't explore it straight away first, I would try and clean it. But what I would normally default to is to kind of just explore it first to try and identify where it's messy. So then you can try and figure out exactly where you need to clean. So maybe let's say you have a date column where it's really messy string that has like 1st of January, Monday, 31st of or something, with a timestamp or something. So say that's in one column. Maybe to actually be able to explore that column, you need to break it apart to figure out what's the date, what's the day of the week, what's the year, what's the time. All of those sorts of things definitely have an impact. So I don't think there's a straightforward answer to explore or clean first, but generally I think try and explore first, and then if you can't explore, then clean the data until you can explore it. Hopefully that makes sense. Bit of pragmatic advice, maybe. Fernando is asking, what do you think about Julia? Me and my close friends are actually very positive on Julia. We think that it's a really cool language, and it might pick up in popularity in the coming years. Whether I recommend learning it now is another question. In terms of it's a really powerful language, and I think it's relatively simple to learn as well. But the fact remains that not many companies are using it at the moment. So you might learn all these amazing 6 skills in the Julia, but if it's not helping you get those roles that you need to learn a lot more about data science on the job, then I don't think that's the right thing to do. What I'd recommend is if you already have a really good grasp of R and Python and some of the machine learning maybe some deep learning as well. Then maybe start looking into Julia as an alternative, because a lot of Julia is very good where you can implement a lot of the math directly in the Julia language without having to use different packages in the Python, for example. So it's just really, I think it's really nice, but it's more focus on the things that will help you first. Julia is an add-on to that, I think. So don't prioritize it, is what I'd recommend. Okay. Ayush, don't worry about your typo. I think I still answered it okay. I think I said evolving instead of dynamic, so it's not too bad. Okay. Pratap's question on software skills, I think the idea is I'm not quite sure what the S is. And tools will improve in future, so data scientists will have to do less of things. Yes, I am very in agreement with this comment. I think it depends, right? So the data scientists, if you want to move more towards a machine learning heavy area where you're doing more of the deployment and you want to try and move over to a machine learning engineer position, which is what I experienced over the past 2 years or so, then you actually need more software skills, and you actually learn the software skills that will do the automation of the things that you don't like doing. So that sort of, for me in my mind, it was sort of like a shortcut to learn how to automate myself out of a job as a data scientist in a funny way. But I thought it was, for me personally, I liked the challenge of learning more of those software skills. And I think having a really good foundation in being able to write good software will always be a bonus, and it will always make you look good within the data science space. If you showed, let's say, a hiring manager gets shown a resume where someone is very good at coding in Python versus someone who is not so good at coding in Python. Yeah, it's maybe that's a dumb example, but yeah, in terms of technical skill, the higher it is, the more likely you are to get a better job. So I think it's always good to invest more time in being a good programmer. Okay. Hamid, should I focus most of the time on exploratory data analysis? This is actually a really good question, and it's I think traditionally what we used to do back in the day, when, let's say, this was like one of those original um, Facebook, Google, LinkedIn data products, for example. Let's say that I would actually bet that they didn't have a lot of features. So today, when we think of machine learning algorithms, you'll see that people will throw in a lot of data in there. There might be tens of thousands of features that go in. And what we used to see is, in the past, you would actually do a lot more exploration, and you kind of handcraft your features that you want to feed to your model. So, for example, you were doing a predicting whether a customer buys something, for example, you would look at very specific features that you could explain and you can understand. And the only way to do that was to really explore your data well. Currently, what we're seeing is there's less of a focus on the exploration of the data and more of a focus on just shove everything in and let the algorithm decide what is going to come out. My perspective is ideally we try and have a balance of both. So what my mentors taught me when I was going through my learning phase was essentially, yes, we deal with big data. We have a lot of features, but there are certain rules that you can apply to the data to try and strip out lots of the features that have lots of nulls, for example. Maybe you have categorical features. You might want to encode them in different ways so you get more value out of them for your machine learning classifier, for example. So I think the exploration of data will be important. I think it's very important and undervalued at the moment. So, but in terms of, you shouldn't spend too much time, like you shouldn't spend so much time that it stops you from actually delivering the final solution that will solve the problem. So it has to be a balance sort of thing. And I think you get that with more and more experience working in the field, where you just kind of have a good intuition for, I think I'll spend this much time on exploration. If I can't do more exploration or there's not enough time, I'm happy with that. And then you move on to the next step. So it's, in the end, having a very pragmatic approach to solving problems with data is usually a great way to tackle it as well. All right. I might do one more question because it's getting a bit late over here, but I really hope you guys had a great time and enjoyed some of the discussion around the HBR articles and the Economist articles and why it really matters in terms of giving you the fuel to try and drive your vision and imagination to figure out where you want to move in your own career. To, I think, understanding the origins and everything is super important and also very interesting as well. You can kind of see the like how the data science was being used in the past and how it actually hasn't changed a lot over time. So I think it's super interesting, and I really hope that you guys got something out of today. Thank you, Pratap, for the comment about my plants. I actually have on that side, I've got like another 10 or so plants that I have to take care of as well. So I love them. They're kind of like my children, but they're really, yeah, I really like them. They make the vibe of the place nice. Okay, awesome. Yeah, thank you so much for joining me today. I hope you guys got some value out of those different articles, and thank you so much. Please get involved. Send me an email or feedback, suggestions. Join me on the Slack channel. If you don't have access to the Slack channel, please hit me with a message on LinkedIn or email. I'll send the link to you straight away. Yeah, just give me as much feedback as possible. I want to make sure that you guys are getting the maximum value out of this and that I'm helping as many people as possible. So yeah, thank you so much for joining me today, and I hope you guys had a great time, and I'll see you. I'm not sure if I'll be on next week because I think I have a really busy week. So I will keep you guys updated to see if I'll actually have enough time to run something next week. But I'll still be online on the Slack to answer all of your questions. So really, really, thank you so much. And awesome, Olu, thank you for thanking my partner. She's a legend. But yeah, awesome. Thank you so much, guys. And I'll see you guys soon. Take care. Have a great night.